Rockets come in a lot of shapes and sizes, and they each have different flight characteristics. Those characteristics are determined during assembly of your rocket. First Nations launch may be your first attempt at building a high-powered rocket. But even if you've built several rockets, we hope this video will help you organize and train other members of your team and provide a few useful tips.
The structure of a rocket is an exercise in weight versus lift and thrust versus drag.
The exterior of the rocket must be aerodynamically optimized and the interior must be balanced and resilient. Together, they must form a safe and stable launch vehicle for a given payload. It is important to run several simulations before choosing your rocket components. Have a good idea of the performance requirements and assembly plan. All high-powered rockets have the same basic parts: nose cone, airframe, and fins. Other exterior components include rail buttons, cameras, and motor retainers. The interior components of a rocket include the motor mount assembly, avionics bay, recovery system, various centering rings, bulk plates, and couplers. The aft section, the rear of the bottom rocket, is called the booster. This is where thrust is generated. The fore section, the front or top, is called the sustainer.
They are joined by a coupler. While many rockets flying H-class motors may be made of laminated cardboard for budgetary reasons, you should consider phenolic tubing, polymer plastics, fiberglass, and carbon fiber materials when flying a high-powered rocket with an I-class motor or above. The nose cone parts the air as the rocket moves up through the atmosphere. The friction of the air pushes the nose cone down, transferring force to the airframe.
The airframe forms the body tube of the rocket, supporting the nose cone and fins. During flight, the airframe receives forces from multiple directions. If the rocket veers to one side or is hit by wind during the flight, the airframe can buckle or break. The airframe must be able to withstand these forces. The fins provide the rocket stability and control. Changes in the air can make the rocket turn. If it turns too much, it can go off course. The effectiveness of fins depend on their size, shape, and surface. If the rocket attempts to turn, the air pushes more on the exposed fin surfaces until the rocket rights itself. The motor mount assembly attaches to the airframe with its centering rings. The motor tube transfers the thrust of the motor to the centering rings, which transfer it to the airframe. So the motor mount assembly must be able to withstand the highest force produced by the motor. After a motor's propellant and delay charge have been burned out, they ignite the deployment charge. This explosively pressurizes the interior of the rocket, forcing the sections apart and deploying the recovery system. However, if the rocket motor is not properly restrained, it will be blown out the aft end of the rocket also. Motor retention components such as rings or clips do not typically come with kits and may need to be purchased separately. A coupler is a tube that's outer diameter is equal to the inner diameter of the airframe, so that it fits snugly inside to connect with multiple segments of the airframe. While these are initially just pressure fitted, make sure to test and use shear pins for launch. Bulk plates are circular discs that fit inside of tubes to separate segments. Remember that when deployment charges ignite, the bulk plates take the direct force, so they need to be well bonded. A rail button is an H-shaped component made of a hard, smooth plastic or aluminum. These buttons mount to the airframe and slide freely inside a channel on the launch rail. These need to be aligned with the fins and airframe for stability and firmly secured with backing to withstand launch thrust. By the time your kit and components arrive in the mail, you should have already organized your team and assigned roles, including documentation of your build process. When building, make sure to follow the instructions and complete each step before you move on to the next step. As always, open the kit and check the contents with the parts list. If something is missing, email the manufacturer and let them know. Most will respond and send out a missing part right away. And as always, practice safety. Use tools safely, use proper protective gear, be cautious of paint and chemical fumes, store everything according to your school safety rules, and keep your workspaces clean. It is important to take rocket assembly seriously. Errors in assembly can lead to catastrophic failures on the launch pad. Try and avoid errors like these. If the body tube ends are not strong enough or the Kevlar extends past the end of the tube, a zipper may occur, causing damage to the body tube. If the motor mount bonds are too weak, the motor may fire through the airframe. While building, be sure to take notes, read all instructions carefully, and dry fit every part to determine if adjustments need to be made. Label everything. Some parts appear identical, But as you drill holes or make cuts or modify components, there will only be one way if it all fits back together perfectly. Many teams have prepped their rockets only to discover that their holes don't line up properly. Remember, the segments of the airframe are cylindrical and can spin. One common trick is to mark or paint a single alignment stripe down the length of the body. You will have to devise your own labeling convention and make sure everyone on the team understands it. A lot of your construction will depend on adhesives. Most kit instructions leave the choice of adhesive to the builder, where others provide specific suggestions as to the type and application of adhesives. So choose your adhesives wisely and be ready to improvise. Some typical adhesives you will use include epoxy, cyanoacrylate, and polyvinyl acetate, more commonly known as wood glue. Two-part epoxy adhesives consist of an epoxy resin plus a hardener. They form extreme strong bonds with most materials and are favored for a lot of rocketry assembly. They come in many options for curing time from 5 minutes to 8 hours. However, they have to be measured properly and mixed together, so it is important to not mix too much at a time and use a timer if curing time is limited. Cyanoacrylate is the chemical name for superglue adhesive which solidifies in seconds and are suited to small plastic parts. Cyanoacrylates have relatively little gap-filling capability, so they require close-fitting joints to bond effectively. Wood glue or polyvinyl acetate has better gap-filling properties. As the name implies, it is most effective at bonding porous materials like wood and paper. A fundamental rule of adhesives is that more surface contact area creates stronger bonded joints. For example, sanding a surface before gluing cuts micro-ridges into the surface, creating more surface area and a better bond. With most adhesives, maximum bond strength is not produced instantly. The assembled joint must be supported in position while the adhesive is curing. Plan ahead how you will keep parts aligned with your adhesive cures. Aligning fins and rail buttons is particularly challenging. Eyeballing, measuring, and holding parts by hand can be tricky, so many teams create custom tools to help solve this problem. Here is a notched fin guide. Here is a laser-cut cardboard jig. And here is a custom alignment bench. However you solve these challenges, make sure you document your process and measure the results. Another common challenge is applying adhesives to the inside of the airframe tube. High-stress components like centering rings and rail buttons will require solid bonding and possibly backing to ensure structural integrity. One common trick is to use a rounded dowel as a long-reach applicator. For critical placement, you can mark distances along the dowel. There are also brushes and applicator syringes available commercially, and sometimes it is just the team member with the longest or thinnest arms. To quickly review, run mini simulations, know your rocket, organize your team, and plan your assembly before you even open the box. Inventory every part, dry fit every part, label every part, and document your process. After you think it is done right, measure, test it, and log it. Keep your workspace clean and be safe. Did we mention safety? Seriously, don't do anything you are unsure of. The most important part of teamwork is keeping each other safe. Enjoy problem solving and ask us questions.
The guidelines in this video are provided by EEE Wisconsin Rocketry Association, host of the First Nations Launch Program at Richard Long State Recreation Area. When launching locally, please check with your local TRA prefecture or NAR chapter.